In 2012, the number of AI studies in ophthalmology was just 9, but it has soared by 400% over the next 5 years. With the development of better equipment, we've made advancements in vision correction surgery from the first-generation LASIK to SMILE. It doesn't mean that a specific surgery is better than another. There are pros and cons to each. This is the corneal topographic patterns of 6 people with similar eyesight. In fact, they are all different in refractive power, corneal shape, and pupil size. This is why each patient needs a specific surgical procedure based on their unique eye conditions. In this respect, the next generation vision correction surgery needs to be customized through AI. AI-based techniques are being used to reduce surgical errors and possible side effects. In fact, research using AI in the field of eye examination and correction of vision has increased worldwide, and there are some cases where the results have been remarkable. In 2018, the Google AI team published a paper in Nature on how AI-based technologies were incorporated into the fundus. A retinal fundus image can be used to identify a patient's gender, age, and calculate cardiovascular risk factors as well as BMI. Google first applied AI, making accurate diagnosis possible, but Korea was the first nation to use the AI-based technologies in vision correction surgery. The bieenvit Eye Center was the first in the world to introduce AI-based technologies in vision correction surgery. As of now, how far have the technologies come? The bieenvit Eye Center's AI system has compiled the surgical records of around 450,000 eyes and still studies more than 20,000 eyes a year. It is equivalent to the data and expertise a doctor can acquire by operating on 50 patients a day for more than 26 years. The bieenvit Eye Center's research papers have officially been adopted by NPJ. According to the research, AI, which studied 26 years of surgical records, are 98.1% as accurate as ophthalmologist diagnosis.
원추각막이나 각막 확장증은 아직까지 그 스크리닝, 진단이 명확하게 이루어지지 않는 부분들이 있습니다. 그래서 의사가 진단을 하고 걸러내는 데 있어서 한계점이 분명히 존재하죠. 의사가 가지고 있는 한계점을 극복할 수 있다면 보다 더 정확한 결과를 얻어낼 수 있고 맞춤형 수술을 통해서 단순히 시력을 1.0으로 만드는 것뿐만이 아니라 고위 수차를 같이 교정하는 수술을 통해서 시력과 함께 시력의 질도 교정하는 작업들을 통해서 수술의 결과를 극대화할 수 있는 거죠.
The graph predicting vision following surgery shows the widely distributed values of conventional surgery, which means average is 1.0, but there also is high possibility of 0.7 or 0.8. On the contrary, the range of values was concentrated near the mean value of 1.11 for the customized group. The AI system compiles 60 different data, including the corneal topographic map, corneal stiffness, and corneal OCT data, and so on, to design the best surgical option for the patient. First, AI system uses an algorithm to read the patient's optic data and evaluate their possibility for surgery. The AI program screens out those with keratoconus and glaucoma that may cause pernicious side effects of blindness with 100% accuracy. Second, it determines which procedure is proper, conventional or customized. At this stage, we can see which surgical option is most appropriate for the patient: LASIK, LASIK, SMILE, or ICL. Third, once the type of surgery is determined, the ablation zone and amount of cornea need to be calculated, which requires experience of medical staff most. The accuracy of bieenvit AI is 98% in nomogram computation. The quality of your vision hinges on how your cornea is designed for surgery. AI derives the possible surgery result value after analyzing various factors such as refractive errors, pupil size, and corneal curvature. AI-assisted vision correction surgery has improved surgery results and patient satisfaction, but we still have a few issues to address. Through the studies of bieenvit Eye Center and Google, we can see the future of AI in the medical service.